Okay, if you don't have any questions in that, I will show the next solution I did yesterday. Acceleration is given as a function of velocity in this problem. So I used the integration method and found the displacement as a function of velocity. And when it stops, the velocity is zero. I substituted v equal to zero to get that displacement what is asked. So any question in this part? Anyone having any question? Can you hear what I'm saying? One or two can say yes. One or two. Okay. Okay, that's enough. Okay. So this problem is the same. So, and then I gave this problem, I did not solve. So is anybody interested or requiring me to solve this problem? And only one? Okay. Yeah. Okay, then I will solve this. Just wait. I'll solve this. Okay. I drew the velocity time variation already yesterday. So I'm going to just apply the equations within those three zones to find the solution to this problem. Just let me find out where I solved it. It will not take more than a second. Yes, got it. Okay. These type of problems we should solve in different stages. First, stage one. The distance traveled in this stage is given as 1000 meters. Read the problem carefully. And the particle is going through constant acceleration. Therefore, if v is the final velocity, we can write v equal to v0 plus ac times t. But we call the t as t1 here and the velocity as v1 there. So v1 equal to the starting velocity, which is 0, plus ac is constant, but we don't know what that is. So AC1, I'm calling it as AC1 because that is for the first part of the travel times. I took the total time for that part as T1, which is this one. From this, therefore, V1 equal to AC1 T1. This is equation 1. A set of equations will result from this. V squared minus V0 square is 2AC S minus S0. We can apply that. So V1 squared minus 0 is equal to 2AC1 times S is 1000 minus starting is 0. From this, V1 squared is equal to 2000 AC1. Let's call this as equation 2. We are getting different quantities connected, but we don't have any of them. So we cannot do much with them as yet. So go to stage 2 now. Stage 2 is simple because it is only constant velocity case. So which is that. And in constant velocity case, the distance traveled at the start is 1000 because already 1000 kilometers, 1000 meters was covered by the previous travel in the previous stage, and the final it is covering another 2 kilometers. That means the final S is 3000 meters here. AC t2 equal to 0. Therefore, the distance traveled s minus s0 must be equal to the constant velocity v1 times the time is t2 minus t1 because we called the time at the end of stage 2 as t2. Therefore, 3000 minus 1000 is equal to, we don't know v1 yet, so v1 times t2 minus t1. We don't know any of that, but we can write v1 is equal to 2000 divided by t2 minus t1. Let's say this is the fourth equation. Okay. Now let's look at stage 3. I will write it here. Stage 3. Stage 2, you can't do anything more because it is just a motion with constant velocity. In stage 3, S0 is equal to 3000 meters because we are starting from there. And final S is equal to 4000 meters because it is traveling for another kilometer in stage 3. V equal to V0 plus ACT. The final velocity at the end is equal to 0, is equal to, the starting velocity is nothing but that V1 because it continued with uniform velocity during stage 2 plus, let us call this as AC3, the deceleration, times the total time is given as 360. So 360 minus T2 is the time duration for this period. From this, V1 is equal to minus AC3 times 360 minus T2. Still, we are not seeing any bright light. They're all getting into different equations, say equation 5. Then in this, we can also use V squared minus V0 square is equal to 2AC S minus S0. So for the conditions of the third um, stage, 0 minus V1 square is equal to 2AC3 times, this is 4000 minus S0 1000. From this, we can write V1 squared is equal to minus 2000 AC3. Let's call this as equation 6. Okay. From that equation, yeah, from here, from 1 and 2, what I can write is, we can actually equate V1 on both sides. Okay. So if you square the AC1 is equal to V1 squared over 2000 is from equation 2, and from this V1 is equal to is also equal to V1 over T1 from equation 1. This is from equation 2, this is from equation 1. By equating those two, we get V1 is equal to 2000 divided by T1. Call this as equation 3. So a maze of equations are generated or is generated. Now we need to just shuffle them around and solve the final problem. I'm doing that here. From 5 and 6 equations, we can say AC3 is equal to minus V1 divided by 360 minus T2, which is from equation 5. But from equation 6, the same.
S0 is 3000.
Yeah. Yeah, this is 3000, that's fine. It's only typographical mistake, 3000. Okay, AC3, and from equation 6, it becomes V1 squared over 2000. And by simplifying this, we will get V1 equal to 2000 divided by 360 minus T2. Call this as equation 7. Now, equation 4 is V1 equal to this. And equation 7 is V1 equal to this. So we can equate both of them. Equating 4 and 7, we get 2000 divided by 360 minus T2 is equal to 2000 divided by, oh wait, okay, yeah, 2000 divided by 360 minus 2000 divided by T2 minus T1. You can simplify this and write 2T2 minus T1 is equal to 360 by cross multiplying, and this you can call as equation 8. We're close to the end. 3 is equation 3 and 7. Equation 3 is V1 equal to this. Equation 7 is also V1 equal to that. If you equate them, three and 7, you will get 2000 divided by T1 is equal to, equation 7 is 2000 divided by 360 minus T2. So from this, T2 plus T1 equal to 360. Call this as equation 9. Now equation 8 and 9, you only have T1 and T2 unknown. So these are two simultaneous equations with the two unknowns. You can solve them easily. Solving 8 and 9 simultaneously, we will get T1 equal to 120 seconds and T2 is equal to 240 seconds. And the final velocity, the velocity maximum, which is V1, is if you substitute in any of those equations where V1 and T1 are connected. For example, equation 3, V1 equal to 2000 divided by T1, T1 is equal to 120. So 2000 divided by 120, if you do that, you will get 16.6667 meter per second. So that is the final answer. So to get there, we had to develop all these equations. Now tell me if you have any questions here. Yep, this is 2T2. Yep, if you can find shorter ways, you can do it. Go ahead and do it. No problem. Perhaps you can calculate the areas under the velocity time graphs at different stages and equate them to the distances given and sort out. So, but I will leave that with you. If you don't have any other questions with this problem, I will solve the next problem. In problems like this, you will always get a number of equations like this. They appear to be taking you nowhere, but you can sort them out. So it is just finding your way through these equations. And you can find better ways, search for them. Any other question? If you don't have any other question, I will move on. So it's a simple problem. You can solve it. And I don't think you need any help here. And this one is also simple problem. You can solve it. I will leave it with you. And I solved this problem in the tutorial last night. If you have any questions in this, please let me know. The trick is to write the equations of velocity here because it is velocity versus displacement. So I used that line and wrote that equation. And for this part, I gave this method and I wrote the equation like that. And once you write the equations, if velocity is given as a function of displacement, we use AdS equal to VdV to get acceleration as a function of displacement, which is this, and substitute s equal to 50, you get the acceleration. Similarly, here AdS equal to VdV gives you acceleration as a function of displacement and get there. Any question in this problem? Do you want me to explain anything further? If you have any question, you can type it in the chat area. If you don't have, then I will move on. Okay, I am moving on. This is a problem similar to the previous ones, and you can solve it. The equations are already given. You just need to differentiate them to get the velocity time functions and differentiate once again to get the acceleration time. Oh no, we integrate once to get the velocity as a function of time and integrate it again to get the displacement as a function of time. And you should be getting those equations and solve it in different stages. So any questions anybody wants to ask me in this? I could not get the plus on when I did this. Which one? Adam, Richards. Let me check my answers. Let me just quickly check and I will let you know. This is It seems to be fine. Yep, it's fine. I don't see any problem there. If you did not get, you need to repeat it. The answer I gave is correct, sirs. So please recheck. I don't want to do the whole of it now. Okay. Yeah, this answer is correct. You should get it and try it again. Try it again. Do the integration properly and it will be fine. Okay. Nothing wrong in that answer, please. Excuse me. Mr. Kumar, have this. Okay. Can you tell me if you have any problem in this problem? Any, this is a problem similar to the previous ones, but we have acceleration versus displacement diagram, and make sure that you know why I am doing this to develop the equation in that part. And you know why I am doing this to develop the equation for this curve in this part. This is just developing the equations of straight lines. Okay. Any question in this part? Anything not understood? So don't hesitate to ask. This tutorial, this session is to help those who are in need. So you can ask if you want anything. Okay, can I go on with the next one then? The formula sheet. I will okay, I cannot do it there. So I will send it, I will upload it online just after the session. Okay, let me note it down so that I don't forget. Any other question? This problem is very similar to the previous ones. I'm not going to solve this also, but I'll give you an answer for this so that you can try on your own just after the session. Okay. Do you want me to give the solution or should I just give the answers? Quickly say yes or no. Okay, I'm giving the answers. Okay. You know how to solve it. So take the first part and then write the equation, and the second part, put it like this, and then write the equation. So just in case, for the second part, the acceleration equation here will be acceleration is equal to s minus 2000. And the final answers are at s equal to 100 meters, acceleration is equal to 11.11 meter per second square. and s is equal to 175 meters. Acceleration is equal to minus 25 meter per second square. So these are the answers. Okay, I'm going forward. Let me solve this problem. A rocket is fired from rest at x equal to 0 and travels along a parabolic trajectory described y squared is equal to 120 10 power 3 x meters. That is the explicit equation between y and x components. If the x component of the acceleration is ax equal to 1 over 4 t squared, that means the horizontal component is varying as a function of time, where t is in seconds. Determine the magnitude of the rocket's velocity and acceleration when t equal to 10 seconds. 10 seconds. So t equal to 10 seconds, we need to calculate the velocity and acceleration. Acceleration, horizontal component we know, but we don't know the vertical component. So we need to develop equations for that. Okay, first things first, the given equation is y squared is equal to 120 times 10 power 3 x, which means, so, and then the ax acceleration in the horizontal direction is 1 over 4 t squared. I'll leave them like that. Let us calculate the x components of velocity and acceleration first. Ax is equal to 1 over 4 t squared, but A is equal to dv over dt. Therefore, dv equal to a dt, and therefore integral dv is equal to integral 1 over 4 t square dt, 0 to t, and this is 0 to the vx component. So on the left side, it becomes v 0 to vx is equal to 1 over 4 times t cubed over 3 between limits 0 and t. So from this, vx, the horizontal component of velocity, is equal to 1 over, right, 1 over 12 t cube. Then the displacement is v is dx over dt. Therefore, dx is equal to v dt. Integral dx 0 to x is equal to 1 over 12 integral t cubed dt 0 to t. So from this, x between limits 0 and x is equal to 1 over 12 t to the power 4 over 4. So 1 over 48 t to the power 4, 0 to t. Therefore, x is equal to 1 over 48 t to the power 4. This is all the story with the motion along the x direction. At t equal to 10 seconds, Vx is equal to, substitute that in the equation for Vx, which is this one, you will get 83.3333 meter per second. Ax, substitute in the equation for Ax, which is 1 over 4 t square, 25 meter per second square. and the distance it traveled x is equal to, substitute in this equation, 208.3333 meter per second. Any questions so far? Yeah, meters, okay. If you say meters, meters. Okay, then go to the y components. Y components, y squared is given as 120 times 10 power 3 x. Y squared is equal to 120 times 10 cube. X is varying, we just found as a function of time, we can substitute that here, t to the power 4. So from this, y is equal to 50 t squared. That is the expression for y. So Vy is dy over dt, which is equal to 100t. And Ay is d over dt of velocity in the y direction. It will become constant at 100. So at t equal to 10 seconds, velocity in the y direction is equal to, substitute in that equation, 1000 meter per second, and acceleration in the y direction is constant, 100 meter per second square, and therefore the total velocity v is root x component 83.3333 square plus y component, which is 1000 square. Therefore, the total velocity 1003.4662 meter per second, and total acceleration is horizontal x component, 25 square plus the y component, which is 100 square. Therefore, the total acceleration A is 103.0776 meter per second square. So, any problem? Any question on this problem? Then I will go to this one. This one is relatively simple problem. The x component and y component are given as varying individually. So you can The flight path of the okay, x component and y component are given individually. Determine the distance that the helicopter is from point A and the magnitudes of its velocity and acceleration when t equal to 10 seconds. So you can just differentiate those to get the velocity components in the x and y direction, and differentiate again to get the acceleration components along the x and y directions. So the answers for this problem are the distance A to B is equal to 203.961 meter, and the velocity is equal to 41.7612 meter per second, and the acceleration is equal to 4.66 meter per second square. Okay, you try this as homework. Okay, this is a projectile problem. Show that if a projectile is fired at an angle theta from the horizontal with an initial velocity v0, the maximum range the projectile can travel is given by r max equal to v0 square over g, where g is the acceleration of gravity. What is the angle theta for this condition? Okay, let's take a simple projectile that is fired from the ground level. Say this is the ground level, and we are firing the projectile from point A, and then it is going up and touching down like that at so call this point as A, this point as B, and the velocity at the start is v0, and the angle at which this is thrown is theta. Okay, what is the maximum range? Range is this distance r. Now we know v0 x, v0 x is equal to v0 cos theta, v0 y is equal to v0 sine theta. These are the x and y components of that velocity. In the horizontal motion, because in projectile motion, as I told in the class, we treat horizontal motion as one event and vertical motion as another event. These two are two discrete events. So analyze the horizontal motion individually. This is uniform velocity v0x traveling for a time t. So the total distance traveled is the range, r is equal to the x component times whatever time it is in flight. Therefore, r is equal to v0x is v0 cos theta times t. We don't know any of those quantities. Let them be like that. That is equation 1. We don't have much to do with the horizontal motion anymore because there is only one equation. Distance traveled equal to the uniform velocity times time. We used it and that's it. But with vertical, we can get further information. So consider the vertical motion. Let me write motion here also. The vertical direction, if you use S minus S0 is equal to V0t plus half AC t squared, because it's constant acceleration in the vertical direction moving against gravity, because the particle at the start A and at the end B, they're all at the same levels. The total vertical distance traveled is 0 minus 0 equal to, it started with V0 sine theta component, V0 sine theta in the vertical direction times t minus half. I told you always substitute minus 9.81 as the acceleration in these equations times t squared. From this, V0 sine theta is equal to 9.81. He wants the solution in terms of g, so I will just use it as g. So 9.81 g times t over 2. From this, t is equal to 2 times V0 sine theta divided by g. Now call this as equation 2. If you use equation 1, r is equal to, what is equation 1? R equal to V0 cos theta times t. But instead of this t, we can substitute equation 2. Therefore, r becomes 2 times V0 square times sine theta times cos theta divided by g. Therefore, r is equal to 2 sine theta cos theta. We can write it as sine 2 theta. V0 square sine 2 theta divided by g. Now, come here. If you want this to be maximum, our velocity V0 is the given velocity. We cannot change it. G is constant. You cannot change it. It is universally constant. And so sine 2 theta is the only thing you can change. Or in other words, 2 theta is the only thing that you can change. Okay, do you know what is the maximum value for sine theta for any given value of theta? Sine theta values vary from 0 to 1. So when sine 2 theta is equal to 1, you will get r as maximum. Therefore, r max is equal to V0 square over g. And that is what he asked you to prove, because sine 2 theta must be equal to 1 for it to be maximum. So this, if it is equal to 1, then R max that you can get is V0 square over g. Then corresponding to that, the condition is sine 2 theta is equal to 1. That means 2 theta must be equal to 90 degrees, because sine 90 is 1. That means theta is equal to 45 degrees. So in other words, if that whatever velocity with which you throw that stone, if you throw it at 45 degrees to the horizontal, you will cover the maximum distance. So the Olympic champions who are throwing masses and arrows and other things, they should be using that angle to get a winning distance for themselves. Is that okay? That is the nature of projectile motion. Any question for me in this part? As you can see, algebra, trigonometry, vectors, differentiation and integration are essentially the background information that is needed for this course. Not only this, any engineering course. So fair amount of expertise in all these areas is an essential part of engineering. If it is already there, it is well and good. But if it is not there, this course is indicating that you should pick up on those areas because engineering is application of these mathematical sciences. Will you give us the info to change to cos sign in the test? No, these are very fundamental aspects. I cannot give that sir because if I keep giving, it will be it will be too much of data. So in other words, there are only 4 standard trigonometric identities you should remember. I did that in the class already. For example, sine, I will give that here. You will realize how simple it is. Sine A plus B. You just remember this. This is equal to sine A cos B plus cos A sine B. This is a trigonometric identity. You can prove it easily. Your NCEA Math Level 3 textbook has proof of this. Go back to it and just quickly review whenever you have time, but don't do it today. So if both A and B are equal to theta, for example, so sine theta plus theta is equal to sine theta cos theta plus cos theta sine theta. On the left side, it is sine 2 theta is equal to 2 sine theta cos theta. So what is required is that one. That brings you to this. Now, can you keep it in your brain or not? This one equation. Yep, that's it. That is, it's not big rocket science. It's just 3 or 4 fundamental equations in trigonometry and a little bit of expertise in differentiation and a bit of expertise in integration and analytical thinking. That comes by solving many problems. That's what we are doing now. Okay, any question in this part? Constant acceleration formulae are given and it is in the formula sheet. I will upload the formula sheet just after this session and you will get that. Okay, can I do the next problem, which is this one? Okay, I will record this part and put it online also because some students missed it. Okay, this problem, it is observed that the time for the ball to strike the ground at B is 2.5 seconds. Determine the speed VA and angle theta A at which the ball was thrown. So he didn't give you VA and theta A, but he gave you the total time. So let's start applying the known equations. First of all, we don't know what is VA, so you take it as an unknown quantity. We don't know theta A also. Carry it forward as an unknown quantity and don't get scared with whatever is developing. Vx, the x component at the start, is VA cos theta A. So we can't do anything more than that, leave it like that. Vy is equal to VA sine theta A. So leave it like that. The total time T for this flight is 2.5 seconds. It is given. Leave it like that. Now, as in any projectile motion, we first analyze the horizontal part of the motion, which is R is equal to the constant acceleration in the horizontal direction times whatever time the particle is in flight. This is uniform velocity case. So from this, therefore, R is equal to VA cos theta A times the time. So can we simplify this any further? We can substitute that time. And also he gave you what is R, 50. We can substitute those quantities. So 50 is equal to VA cos theta A times the total time is 2.5. From this, we get VA cos theta A is equal to 20. Call this as equation 1. We have two unknowns and one equation. We can't do much with that. So let's go to the vertical motion. The horizontal motion, we have exhausted it fully. We don't get any further information from there. In vertical motion, we can use those constant acceleration case equations, but only two of them because the third one is dependent equation. Say SB minus SA in the vertical direction must be equal to V0t plus half AC t square. If you apply that equation, say if you take the origin as that level x and y, because he didn't give any other information, we can take that as the origin. So SA is SB is below origin at 1.2. So minus 1.2 minus 0 is equal to V0 is VA sine theta A times, I can substitute time t, which is 2.5, which is given, minus half times AC is 9.81. Always substitute negative g in these equations, times 2.5 square. So if you simplify this, you will get another equation for VA sine theta A as equal to 11.7825, that is equation 2. So now you can see some pattern there. If you divide equation 2 by equation 1, on the left side, VA and VA get cancelled. Tan sine theta divided by cos theta is tan theta. So tan theta A is equal to 11.7825 divided by 20. By taking inverse tan on the right side, we can get theta A as 30.5034 degrees. If you know theta A, therefore VA is equal to 11.7825 divided by sine theta A, 30.5034. So from this, the velocity at the start is equal to 23.2127 meter per second. So that is it. Now tell me if you have any questions in this part. Mr. Zinzao Zhu, any questions? And also, just remember, sine A plus B, I told you just now, sine A cos B plus cos A sine B. What is cos A plus B? Cos A cos B minus sine A sine B. So just these two identities, if you remember, you can extrapolate them to get into many different forms. Okay, if you can see, there are so many different ways you can solve these problems. And as long as the solution is correct, you can use any method. I just solved in a method that most students in the class can understand. So as long as your solution is correct, you can approach these problems with any method. And remember, um, at the end of the course, you will realize that most of the methods that we are using will be superseded or will be kicked out by more elegant methods like energy method and impact equation, the conservation of energy. So they will help you to solve these problems in a much, much easier and much better way. So it's only the beginning. So there is no end to inventing better methods here. But right now, tomorrow is the test. You need to pick up the fundamentals on this. So I'm targeting the ones who cannot completely solve most of these problems so that they have some way to go around these within the time that we have. Okay, then this problem I solved in the class today, and I will put that solution now because this problem is solved there. I will go there. So before we go there, do you have any question here? Yes, everything up to now and up to whatever. So whatever I did until this morning in the class, so it is all part of the test tomorrow. There will be 3 questions. Each one is 15 marks. So total time is 45 minutes. Okay. Yep. All right. What I do now is I will just give you 5 minutes break, and in the meanwhile, I will save this as a PDF and upload it on to Blackboard so that the others who are unable to get into the room will have this immediately. And after 5 minutes, I will take out these curvilinear problems using normal and tangential um, equations and solve some more problems there. And don't go away. It's important that you learn these things. Let me just save this.